Okay, there's a new threat quietly making its way into enterprises that are using autonomous AI. And look, this isn't some simple tech glitch. We're talking about a corporate governance nightmare just waiting to happen. So if you're a risk manager, this needs to be right at the top of your list. Let's break down what this AI memory pollution is all about.
Just imagine for a second that this report hits your desk. I mean, this isn't science fiction anymore. This is the high-stakes reality of a brand new vulnerability, one where your most trusted, most productive AI assets can be silently turned against you, using their own memory as a weapon.
All right, so here's how we're going to tackle this. First, we'll unpack what makes this a new kind of insider threat. Then, we'll get into the nitty-gritty of how an AI's memory actually gets poisoned. After that, we'll look at the huge systemic and legal risks, lay out a defense playbook, and wrap up with the new mindset required for governing this tech.
So we're not just talking about simple chatbots anymore. We've moved on to these stateful, autonomous agents that have long-term memory. And that persistence is exactly what makes them so powerful, right? But it's also what creates a brand new internal attack surface that is incredibly difficult to keep an eye on.
This right here forces us to completely reframe how we think about AI security. This is no longer just an IT problem to solve. When an agent can act on its own, its security becomes a matter of high-level corporate governance. You literally have to treat it like a trusted executive with the keys to the kingdom.
Okay, so if these agents are like your top execs, how in the world do they get compromised? Well, to really understand the danger, we need to look at the specific way this threat works. And trust me, it's fundamentally different from the AI exploits you've probably heard about.
The official term is memory poisoning, and it's actually recognized by OWASP as a top-tier threat. It's not about tricking an AI for just one response. No, this is about deliberately corrupting its knowledge base, its memory, to turn it into a long-term internal mole that influences every single decision it makes from that day forward.
Now look at this comparison, because this is really key. We hear about prompt injection all the time, right? But notice how it's transient. It's over as soon as the session ends. Memory poisoning is the complete opposite. It's persistent. It sticks around across sessions, for weeks, maybe even months. And check out the visibility row. The attack and the malicious action are separated by time. That makes it an absolute nightmare to detect.
And this is what makes it so unbelievably insidious. An agent can be compromised without any direct user action at all. It just does its normal, routine background tasks, scanning emails, checking a news feed, and it silently absorbs malicious information, storing it away as if it's a learned fact. The poison is now in its memory, just waiting.
So a single compromised agent is bad enough, but the problem just escalates exponentially in a corporate environment. It creates these massive systemic risks, and for anyone managing risk, it creates significant legal and financial liability. This is where it gets serious.
And we're now seeing some pretty advanced threats. Think self-replicating AI worms that can jump from agent to agent across your network, exploiting the trust that's built in between your internal systems. We're seeing attacks that hide malicious code in developer tools, and these sleeper agents that can just lie dormant for months, waiting for one specific rare trigger to cause the most damage possible.
And just look at this number, almost 78%. That's the success rate for making one of these sleeper agent backdoors stick when it's planted in an agent's memory. This is not a bug you can just patch. It's a learned behavior that is incredibly difficult to root out.
Which, of course, brings us to the inevitable question. When one of these agents goes rogue and causes harm, who foots the bill? For years, there's been this accountability vacuum, but that is closing, and it's closing fast, as regulators are now moving quickly to fill it.
And here are the new rules of the game. Out in California, a new bill explicitly prohibits companies from using the AI did it defense. Nope, liability now falls on anyone who developed, modified, or deployed the system. The EU's AI liability directive goes even further, placing the main burden on the deployer, that's you, and requiring you to prove you had control over the agent.
Okay, so the threat is real, the liability is becoming crystal clear. How do you defend against all this? Let's walk through an actionable playbook you can use for mitigation and governance.
A truly robust compliance program has to cover several key bases. Now, this is a condensed list, but it's the core of it. You absolutely need a full inventory of your agents. You need strict permission audits where read-only is the default. You have to have complete traceability for every single action, runtime controls to block dangerous commands before they happen, and a clear incident response plan that includes being able to roll back and force the AI to unlearn the poison. Now, policy is one thing. You've got to have the tech to back it up. And these technical defenses are absolutely crucial. You have to treat each agent like a unique identity to govern its memory. You need to isolate memories so that one user's corrupted data can't infect another's. You have to track the origin, the provenance of every piece of information the agent learns. And finally, you need what are called semantic firewalls that can actually understand and block malicious instructions being passed between your agents.
You can even use a bit of clever math to fight back. The idea is pretty simple. A memory's influence should decay over time. This formula automatically lowers the trust score of older memories, which makes it much harder for a sleeper agent that was planted months ago to suddenly take control. More recent, verified instructions will always carry more weight.
And when a compromise does happen, you need the ability to make the AI forget. It's called machine unlearning. You can either try to completely erase the bad data from its neural network, or you can suppress it, basically teaching the model to never, ever act on that information again. Think of it as the right to be forgotten, but for your enterprise AI.
So all of this really points to a fundamental change in how we have to approach security in this new age of autonomous AI. The old models, they just aren't going to cut it anymore.
And this brings us to the real bottom line. We can't just build walls around our AI systems anymore. We have to manage what's going on inside them. Security has evolved from just monitoring simple inputs and outputs to the much more complex governance of an agent's identity and, most critically, the integrity of its memory.
Which really leaves us with one final critical question for every leader and risk manager out there to think about. As you deploy these powerful new tools, have you really done the work to make sure your agent's greatest strength, its memory, is truly an asset? Or have you inadvertently created your company's biggest and most persistent liability?